Okay, just so you guys know, I'm going to be streaming this. Hi guys, I'm Alex. I am a student at BYU. I graduate this April, so it's really intimidating being in front of all of you super professional people and talking about my hobby. And I hope that you like it and find it interesting, and I hope that you make it worth your while for coming here. Yeah. Um, so I'll show you my favorite spaceship in just a little bit. But first, a little bit about me. This is me and my wife and a dinosaur, just to make sure that we're clear. I am the one with the sunglasses, and my wife is the one with the hair, and the dinosaur is in the background. So she's really awesome and super supportive. And the point of this talk for me, I don't know why you guys came here. I hope that we get to play with spaceships just a little bit tonight. But if we don't, I put this together just to talk about some of the lessons that I've learned. The number one lesson that I've learned is having a spouse that's super supportive is really helpful when you're working anywhere, side projects or a job or whatever. Those of you that are married, I'm sure you know. So yeah. We're going to talk today about the history of spaceship controls. Yeah, there's a history. Like what? How far back does this go? Back into the late 80s, actually, believe it or not. I'm going to talk about how I built this really big project, basically by myself, and some challenges and pitfalls and lessons that I learned, like I said. So, here's what not to expect, though. We're not actually going to go to space today. I don't actually have a spaceship. Bummer. But shout out for awesome spaceships. The NSEA Protector is up there in like cool ship designs, and yeah, they're just cool. So, who's been to the Space Center before? Raise your hand high in the air, just like this. Who knows what I'm talking about when I say the Space Center? I'm talking about the space adventures type centers where you take the role of a crew member on a futuristic spaceship. Guys, your minds are going to blow. Yeah, you've been. I saw you there, so I know that you've been, but nobody else? Okay, guys, I hope you get the opportunity to go sometime. Here's the wild thing. This right here is the first of these space centers to be constructed. This guy named Victor Williamson was an educator in Pleasant Grove at Central Elementary, and he did this little thing, kind of, I'm trying to think of the word. He just wanted to do this thing to engage the kids, to get them interested in science and math and stuff. And so he had this little role play where they were the crew of this spaceship. And it worked so well, the kids loved it so much that he got a bunch of grants and built that spaceship. So you can see the captain sits up there, the engineer sits up here, they have their computer screens, you've got the navigators over here, and over here you can't see it, but you have the weapons officer, and then if I was standing right here, this is where the security would be. So they have these hand phasers that they can use to shoot the bad guys that might intrude on their ship.
Where is this?
This is in Pleasant Grove, okay? So actually, this is the latest edition. So the Voyager here was built in the year 1990 and ran for 23 years, bringing in classrooms for field trips, doing overnight camps. This is a ship that actually has 2 decks. So there are bunks on the lower deck where the students could sleep. So they do these overnight camps, summer camps that would last for days. The students would come in, they'd be given positions. So one student would be the captain, one would be the engineer, the weapons and the navigator and the communications and everything. They'd be trained on their jobs, and then they would be given a mission. Like, go to this star and study it, find out if it's going to go supernova, or go to this planet and study these aliens that we haven't made first contact with, or go negotiate with these aliens, use aggressive negotiation if necessary. And then they would go and do it. And it's lots of fun for the students, it's lots of fun for the staff, and this program is still in operation, still running. This ship, unfortunately, was shut down due to some code violations, because it was built so long ago by a bunch of amateurs. And this is the latest iteration of that ship. It doesn't exist in the same school. This is a ship in Renaissance Academy in northern Lehigh, and it was built in 2015. and you can see my head, my wife's head poking out of there. But yeah, you might be surprised, but these ships are actually all over the place. So we're right about here, okay? We have one over here in Saratoga Springs called the Lionsgate Center. This one at Renaissance Academy in Lehigh called the Renaissance Space Academy. This one in Northern Pleasant Grove called the Discovery Space Center. This one in Vineyard called the Telos Discovery Space Center. They're related, but they're good. And then this one here, which is the original one in 1990, which is the Krista McAuliffe Space Center. All of these places are open to the public. You can book missions there. You bring a group of people, you come to the Space Center, and you have this experience. You can think of it like a super interactive movie, and it's relatively close to the same price with as expensive as movies are. So shout out to these space centers, and if you want more information about how to book these missions, talk to me afterwards and I'll send you to the right place. But we're going to talk about the controls. Yeah?
So they're great. My daughter actually had a birthday party, birthday parties at the Discovery.
Mm-hmm.
So, yeah, they have lots of fun.
It's super fun, and it's great for adults too. Kids can love it, adults can love it, and obviously I love it because I make controls for it. Yeah, it is kind of mind-blowing though that just here in this pocket of Utah you have all of these space centers, and not really anywhere else. There are some from an offshoot in Pennsylvania, and there's one in Venezuela, oddly enough, and then these 5 here. So yeah, I'm going to talk about the history of the controls, because back in 1990 we didn't have super fancy things to develop controls with, and the guy that built the Space Center, Victor, he didn't really know how to program, so he used the tools that were available to him at the time, and that was HyperCard. Who's ever heard of or used HyperCard? What can you tell us about HyperCard?
So it was on the Mac. I don't know what version it was, but in the 90s.
Mm-hmm.
It was one of the standard tools that you could buy and install on it. And you could basically create screens and have buttons that could jump to other screens. You could put parts and mystery actually.
That is like HyperCard's claim to fame.
The original Myst.
The original Myst, yeah. If you ever played the original Myst, that was built in HyperCard. The spaceship controls were built in HyperCard. We used to say at the Space Center, HyperCard builds character because it's a little bit clunky and doesn't provide a whole lot of good developer experience. Like he said, it's built with stacks and cards. That's the terminology they use. So a card is a screen, and a program is called a stack because you have a whole bunch of screens all stacked, these cards stacked together. In the Space Center world, it was networked together in a kind of kludgy peer-to-peer communication type way over AppleTalk, which was Apple's networking protocol, which was really awesome. Oh, I'm sorry, I'm having flashbacks. Huh? Something like that. It's actually happy flashbacks. There were some bugs with it, and so the way that the Space Center works is you have the students that are on the bridge, and then you have a control room behind the scenes where a flight director acts as like the game master, playing all of the characters, using the controls to manipulate what's on the students' controls, and helping the students along with their mission. And whenever they would start the flight, they would reset all of the computers. They would do training mode on the computers to train them on how to do their stations, and then they would reset everything so that they could actually begin their mission. And whenever they would reset, the main computer would come on and say, if a white box appears, simply click the OK button. And what the students don't know is that white box is actually the authentication process for getting this AppleTalk peer-to-peer communication set up. And it's just one of those things that it was what it was. But it worked, and it was actually incredibly stable, which was kind of weird. Back in the day when the Voyager, that first ship that I showed you, was still around, Victor, who was still in charge of the Space Center at the time, said, "You programmers do not touch the Voyager ever, unless you absolutely have to, because it's perfectly stable, and if you touch it, it'll break it." So we never touched the Voyager, we only worked on the other ships. But this is kind of what it looked like. This is actually a really terrible screenshot because I don't have the fonts, but very simple. You can do these raster graphics and these bright colors, I guess. Yeah. That's for loading torpedoes. So you would take a warhead and stick it into the casing and then load it into the launcher and then shoot it off into space. This is the main reactor core, so you can change the reactor efficiency and the power converters and the plasma conduits. And over here is where you can switch between the different cards, the different screens that they can use. This is for a different ship called the Galileo, which is actually one of the most fascinating ships because it's actually constructed. You can see it's a shuttlecraft-sized ship, and they actually built the shuttlecraft. So you can go into the cafeteria of the school where this is at, see it there. It's in all its glory. It's beautiful. But its original controls were built with hypercards. So this is thruster control for moving the ship around, and then this is the torpedo control for loading torpedoes and firing them off. HyperCard was really cool. Like you said, though, it had a shelf life. It actually was killed with Mac OS 9 when Mac OS 10 came out. Couldn't use HyperCard anymore, so we needed to move to a different programming environment. And the programming environment that was chosen is called LiveCode. It used to be called Revolution, but then change in management, they changed it to LiveCode. But when I was programming at the Space Center, this is what I learned to program on back when I was in junior high, and it was called Revolution. It's like HyperCard, only fancier. It still had stacks and cards, and the scripting language was basically the same, but it had a lot more features and integrated with the system a little bit better and just worked better. And it ran on Mac OS 10, so that was good. Somebody created a TCP/IP networking stack instead of AppleTalk, which was a step up. Didn't have the white box that you had to click on anymore, but it was still peer-to-peer, so it was not super great architecture. But it was really easy to learn. And this is actually the first, I'll get to the lessons learned in a bit. Sorry, I can't remember my slides. But notice the difference here between this and this. It's single colors, very pixely and blah. I mean, it looks fine, but it's not super great. And then you have this with the beautiful graphics and the gradients and the transparency and the reflection, just above and beyond when it comes to the visuals. So that was kind of fun. This is the tractor beam for pulling objects into your ship. Torpedoes loading. Yeah, this is for a different ship, but totally different layout, and the shields protecting stuff outside, and the weapons loading and firing. Yeah, so from LiveCode, these are the things that I learned. Number one, simple is effective. These controls were fairly rudimentary, not very complicated. The networking system was very straightforward. You send a message to this computer, and it does the thing that it's supposed to do. You can't get super complex with that without falling into a whole bunch of pitfalls, but it worked. Like I said, I was learning LiveCode when I was in junior high. And there was actually a whole programming class where they would teach this to kids my age, and they would learn it. It was great. In my opinion, this is just my opinion, but as I've gone on, in my much better than powerful and performant. Who's ever heard of or used Scratch before, or seen someone use Scratch? It's the visual programming language made by MIT, and it's become popular through a whole bunch of programming systems, and I've seen students 9, 8, 9, 10 years old just really latch onto it. Programming for most people is like, that's really scary, but these students get onto Scratch, they learn how it works, they're learning how if statements work and loops and everything, and they're actually learning real programming just in a much simpler way. And I think that's definitely the best place, especially for people starting out. I wish that I learned this one 2 years ago. It's only been recently that I've learned. It's very difficult to teach complicated programming to youngsters. And there you go. You don't know what you don't know until you know better. I didn't realize how good I had it with the ability to teach LiveCode to students until I started trying to teach more complicated things later on. And that's what we're going to get to, is the more complicated simulated controls. Does anybody have any questions? Okay, I know that I'm lecturing a lot. I hope I'll try and keep it down a little shorter, but yeah. Bear with me. So Cocoa, which is the Mac programming environment. This was the future. Revolution was going by the wayside, and Coco was going to give us everything that we possibly wanted, 3D views and super fancy server architectures and the ability to run the same controls on multiple simulators. Because with live code and with HyperCard, we would actually, as developers, program a new set of controls for every single simulator. Every ship would have an entirely different set of controls, so that's why you saw the visual differences between those. And I know this is the Linux User Group, and it was Mac only, so that's true, that's true. But in this case, it couldn't run on anything but Mac, which was a real downside. Actually, when we went to build the new Voyager, because we didn't have a good set of simulator controls available to us at the time that would work for that ship, we had to go with all Macs. And it was really expensive, because Macs are expensive, so that was kind of a bummer. But this is what it looked like. I mean, visually, it's pretty similar. The programmers tried to do some interesting, so I didn't actually develop this. This was an entirely different set of programmers. And they tried to do some avant-garde things by making it so that you could theme it and style it and stuff, but I don't know, it didn't really come out super well in my opinion. But I'm biased, I like my own stuff, so. But yeah, this is the science screen where you can configure probes that you can send out into space. And this is the dilithium crystal for providing power to the ship. And I'm pretty sure that all of that was animated, so you have these beautiful videos. And then this was for the transwarp, which is like super warp. It can go really fast. It's what the Borg use. Yeah, ludicrous speed. So, it's interesting to note, these controls that I'm showing you, other than HyperCard, they had a shelf life of about 5 to 7 years. So we would develop controls in live code, and the simulator would use them for about 5 to 7 years, and then they would switch to something different. And typically that was Mercury. And then Mercury would last for about 5 to 7 years, and then all of the space centers and flight directors would be like, well, this is just not working anymore, we need something new. Along with that was the Voyager, that new Voyager simulator that I showed you. It was being built, and it was an incredibly complicated ship. So now that we had these controls that were very versatile and could do a whole lot of interesting things, we wanted to tackle the next thing, which was the control room. Let me show you some pictures of the control room. This is actually really interesting. Let me see if I can get the lights down at all. Oh, it's fading. Okay. Oh, no, wrong. I guess that works. Yeah, those aren't very bright. So this is one half of the control room of one of the ships at the Christopher College Center. So this is the core computer, which has all of the controls for controlling the students' computers, a voice changer, an iPod for playing music, a video screen here for playing DVDs, for previewing those DVDs, and a screen here for the tactical view screen, which was like a glorified PowerPoint that would show tactical maps of what's going on outside their ship. Smoke machine up there, a soundboard here, there's another soundboard down there, DVD players, CD player over there. This is the other half. This is the light board, so all of these light switches control different banks of light. This one here switches from red lights to blue lights. So red lights if they're at red alert. They've got a telephone here and a camera system, so you can see all of the students in the simulator, and it's a mess. With the Voyager, it was going to become even more complicated. So Flint is the name of the next set of simulated controls that were worked on. I worked on these controls with my brother. This is the floor plan for that Voyager ship. Most of the ships were single rooms. Even the Voyager, the original Voyager, was basically a single room that spanned 2 floors, but it didn't have any kind of separation with the video or with the sound effects or the music or anything between those 2 floors. It was all just one big room. But this ship was designed specifically so that it could be multiple rooms. You have the main bridge here, which is where I showed you that photograph before. You had a sick bay here, and an engineering room here, and then a brig here where the security could put the bad guys, and then this hallway here that spanned all the way around You have a briefing room here, and then a transporter type room here. And then the control room was this area right here. So a whole lot of discrete areas that the flight director wanted to be able to send different video to this room, and to this room, and to this room, and have different audio go to this and this and this room, and have a special sound effect that plays whenever the security officer throws a bad guy into the brig for turning on and off the brig force field. So being able to isolate the sound to this specific area. Super complicated, not something that could be done with just simple over-the-counter equipment like was done with previous space centers. So we decided we were going to create some software-controlled solutions. So that's what Flint was for. It was going to integrate the audio and the sound effects all together, make it so that you could control the lighting with the software and have it integrate with the controls. So if the students change their alert condition on their computers to red alert, it will automatically change all of the lights to red instead of the flight director having to flip the switch. Make it so you have multi-channel, multi-room audio, and being able to send different sound effects to different places based on the context of the sound effect. Making it so that the view screen is dynamic and automated. Instead of having, literally, it was 5 DVD players just stacked on top of each other with a switcher that they would switch between these different DVD players for whatever they wanted to show on the screen. Plus, they had that tactical computer with the glorified PowerPoints. Wouldn't it be nice if that was all together, just one computer that shows everything, plus if it knows what's going on in the simulation, it can automatically choose what to show. Having a built-in voice changer and panel integration. When I talk about panels, I'm talking about hardware, physical switches and buttons and cables that you can switch. Wouldn't it be cool if these could talk with the controls? Something that was tried multiple times in the past, but nobody ever actually succeeded. So wouldn't that be cool if we could do all of that? Now, I know I'm talking a whole lot. Does anybody have any questions at this point? Okay. Once again, if you have any questions, just throw your hand in the air. A couple of other things that were interesting about the Flint controls. It was the first web-based simulator controls. We built it with Meteor.js, which is a JavaScript framework that bundles Node and the front end all together. It was kind of like, I don't know. This is my first taste of web programming, so I don't know a whole lot of frameworks that existed that did what Meteor.js did before Meteor.js. Now you have things like Webpack and Babel and all that stuff, but that didn't exist. This came out in like 2013 and was really cool. The best part about Meteor.js was it was real time, so you could just send the data wherever you wanted, but you had this centralized database of all the information. So if a client goes offline and then comes back, it automatically knows exactly where it's supposed to be and what data it's supposed to have. Yeah, so spoiler alert, Flint actually didn't come about. It was never finished. The code is online if you want to check it out, but we never completed it, and it never actually became used as a set of simulated controls. I'll show you screenshots of this later, though, because I took a lot of the stuff from Flint when I started working on the next set of simulated controls, which we'll get to right now. But first lesson learned, when I refer to skunkworks, that was the term that was used by Lockheed Martin for their experimental division. I mean, correct me if I'm wrong, I might be totally wrong, but that's the way I think of skunkworks. And that's really interesting. It's fun to kind of experiment and innovate and try new things, but it's also fine to throw out useless innovations. One of those things was a voice changer. My brother was working on this JavaScript-based voice changer, which in retrospect sounds like a really bad idea. And he got it working, and it sounded pretty good using the web audio API. But one of the things which the hardware voice changers that the Space Centers use is a formant, which is basically a fast Fourier transform on your voice. JavaScript cannot do fast Fourier transform fast. So now that WASM WebAssembly is a thing, maybe we can go back and see if we can get a voice changer in JavaScript, but we had to scrap that one. Burnout is real. My brother and I were working on this pretty much independently. Nobody else was really contributing. And he was the first one to go. He was just like, I can't do this anymore. We're not getting any traction. We're not going anywhere. This isn't fun anymore. And then I kept on working for a couple more months, and I was like saying, I can't do this anymore. You got to make sure that you have good, I mean, So I'm a student in the information systems department, and one of the things that we focus on is good user experience. Make it so that your users like it so that you can actually sell it so you have customers. But just as much as you need to focus on user experience, you also have to focus on developer experience. If you're not enjoying yourself, you might as well just not, because it's, especially for side projects like this, because you're going to burn out, it's not going to be fun. That's something that with the current set of simulator controls I've had to monitor very closely. One thing that was very interesting about the Flint controls is the fact that while my brother and I were programming them, the product design was entirely by committee, which was slow and tiresome progress. We got a lot of interesting things talked about, but nothing actually got done. We didn't make any decisions. And that meant that my brother and I were stuck frustrated, not knowing what to actually work on, because nobody could make up their minds about how they wanted the controls to operate. And then finally, don't get tied down by your framework. Meteor is awesome, really cool, but it also locks you into a lot of things. You have to do it with Mongo. You have to do it with their build process. I think that things have changed in the more recent versions, but when we were working on it, we couldn't expand out and refactor things to make it work better for us. So part of the developer experience was we got locked into our framework, and that was kind of miserable. So with that, I decided to start over with a new set of controls that I call Thorium. I started with a bunch of premises in mind. With all of the lessons that I've learned in the past, how can I make this actually work this time? So here are my goals. It was built with React and GraphQL, and then Elixir, Docker, RethinkDB. I tried those out and decided, no, this isn't going to work, and then just stuck with Node. But instead of using Meteor this time, I decided to build my own framework type thing on top of other frameworks. Number one goal was to learn. I didn't know React or GraphQL at all before I started these controls, and so I used it as a platform for me to learn. And I didn't want to have the same problem that we have with Flint, where people were saying, I want this, and I want this, and I want it to work this way. I was just going to build it, and I wasn't going to tell anybody about it until I felt like it. I kept it a secret, and it was kind of insane when I dropped it and said, hey, I made these simulator controls. Nobody saw it coming, which I thought was awesome. I wanted to build a team to work on it with me. Since it was just my brother and myself working on it before, that was good. We kept momentum and motivated each other, but having an even bigger team would mean more momentum, right? That'd be great. That's part of the reason why I dropped Elixir, Docker, and RethinkDB, because I wanted to keep it nice and simple and not have to have other people learn Elixir, Docker, and RethinkDB. I figured Node was pretty ubiquitous. If people didn't know Node, they could learn it and it would be super valuable because Node is everywhere nowadays. I don't know what you guys' preference is, but I'm a huge JavaScript guy, so apologies if that offends you. And it was going to be the first open source simulator controls. There's the link. You can go and check out the simulator controls right now. None of these other simulator controls were open source, so I was like, yes, we can make it so that outside contributors, people that aren't stuck in this ecosystem, can contribute, and that'd be awesome. And then finally, I wanted to finish the dang controls because Flint still hurt. I was like, oh, we didn't make it. I want to finish it this time. So that was where I started from, and as I was building these controls, a lot of things changed and my focus shifted, but that's basically where I was coming from. I do want to point out that a lot of the innovation, a lot of the ideas and concepts that I brought into Thorium came from these other frameworks. So I wanted composable cards like Mercury. Instead of having one set of controls with a predefined set of stations, like we did in HyperCard and LiveCode, I wanted to be able to say, okay, here are the different screens that you can use, and you can put them on any computer that you want, in any configuration. And that happened. I wanted to build in effects controls for lighting, sound effects, view screen, everything, like with Flint. And since Flint was built with JavaScript, that was a lot easier to port over than some of these other things. I wanted to design it for configurability to make it work for any other ship. This is the big thing that was really different. Like I said, the Voyager, that first ship that I showed you, it was shut down in 2013, and the entire Space Center actually shut down with it. While the Space Center was shut down, there were other space centers that began to pop up. So those 5 space centers that I showed you on the map, only one of them existed in 2013, well, and then it didn't. And then those other space centers began popping up after that. So now, instead of having just the 5 ships at the one space center, you now have 12, a dozen ships that all have these needs for controls, and you don't want to have the same, like, you don't want to have the same problem where you have to build one set of controls for every simulator. Wouldn't it be great if everybody could use the same set of controls? And everybody gets the updates. So I wanted it to work for any ship, and even like not spaceship type settings. So make it work for submarine missions or what have you. And then make it so that there are multiple layouts and themes so that everybody can look and feel different. And then innovate, build on top of these things. So make it so that we're flying flights, not ships, which I realize now that bullet point only really means anything to me, so don't worry about that. I wanted to give power to the flight director and make it possible for them to not have to think about the controls so much, but focus on the experience that they're creating for the students that are in the simulator. So with that, I built in the automated mission timeline, which makes it so that instead of having to manually change the controls and the video and the sound effects and everything, they can just, at a push of a button, continue on the progress of this linear timeline. It's an optional feature, so if they wanted to, they could go off and do whatever they felt like as part of their game mastering, or they could follow this prescribed timeline depending on the situation that they're working on. And then another innovation that I built in is something called the core feed, which is actionable notifications. Before, in order for the flight directors to know that anything had happened, they'd have to look at their screen and see if anything changed. But now, whenever anything happens, it pops up with a little thing that they can click on, and then they can do whatever needs to happen based on the context of the notification. So I felt proud of that one. I think that's pretty cool. So what happened? I started in June 2016. I went public in June of 2017 and started telling everybody about it and drumming up some support. And then I began doing some full-scale in-simulator testing in 2017, October 2017. It's really nice that I have lots of friends in the space centers because it means that I can go to one of these spaceships and say, hey, can I use your spaceship for 2 hours? And they say, sure. And I get to play with the spaceship for 2 hours, which is awesome. Also awesome is I get to bring my family along. So this is my in-laws. I brought them to the Space Center. They had absolutely no idea what they were getting themselves into. I don't think that my father-in-law has forgiven me. He is not pictured in this photo, but that's okay. We're on okay terms regardless. So I've got cool family, though. They're really awesome. And Grandma there, she rocked it. She was the star of the show. So there are 5 bullet points here. Each of those 5 bullet points is the space centers that have decided to start using Thorium in their schools, in their programs. So the Lionsgate Center in Saratoga Springs, the Chris McCall Space Center in Pleasant Grove, Discovery, Telos, Renaissance, all of them. I have 100% market share with these controls in all the space centers, which I'm going to get to why that sucks, but it's awesome. I really am proud of that. Side projects are awesome for learning new stuff. I am actually kind of disappointed. I feel like I've finished these controls. Like, there's always more to be done. There are 93 issues on GitHub that I'm going to get to one of these days. But I feel like I've learned everything that I wanted to learn from this, and that's awesome. I'm really kind of disappointed, too, because I want to keep learning more stuff, but I don't know how to do that with what I have right now, so I'm going to have to find a new side project sometime. Number 2, build your team from the get-go. Later might be too late. I've been trying for the past 2 years to build a team of people to help work on Thorium, and there's been some interest from people at BYU and people at space centers and stuff, but I haven't gotten anybody to continuously contribute to the code, which is fine. It is, like, I will humble brag for a moment and say it's kind of cool that I've written all of this code. If you want, I'll run CLOC really quick and see how many lines of code it is. But really, it would be really awesome to have a team working on this. It's open source, you can contribute. That's not the first time, the last time that you'll hear me say that. Making enterprise/configurable software is tough. I don't know if any of you guys make real enterprise software. I do not make real enterprise software, but this feels like it to me because the way that I picture enterprise software is it works for everybody. I don't care if you're Google or Microsoft or whoever. You can use this enterprise software and we can make it work for you. by configuring it a lot. And it's all that configuration part that's really hard to program, which is why enterprise software is really, really expensive. And being dictator of your own projects is really nice. The fact that we didn't have a committee, I could just make the decisions that I wanted for how to work this project and what to build and when I wanted to build it was lots of fun. I really enjoyed it. But it comes with some downsides. It can get lonely, but you can contribute and make it not so lonely. If you want customers and users for your projects, you got to get stuff in front of them fast. This has been one of the things that I did not expect to learn from Thorium, but I did. And that was customer and product management. Going to the customer saying, what is it that you want? And then having them come back to me and say, this is what I want, can you make this happen? And working together with them to figure out what exactly it really is that they want. It's been really rewarding and really interesting. And I know that the code and computers and stuff is really fun and really great, but what really matters is people. And that kind of goes both ways. I actually read an article recently that said it was about an algorithm that solved all of the problems regarding school buses for this district in Boston. And it was going to save a ton of money, it was going to save time, it was going to make it so that high school students could get to school later, which meant that they could sleep in, which is good for their health and mental state and whatnot. And when they brought it up for a vote, it was voted down because the people, the parents, didn't like it. They didn't like the results of this perfect algorithm. So people are not only the biggest cause of problems, but they're also the greatest pleasure, joy, and reward of solving those problems. So it goes both ways, as most good things in life are. Yeah, I kind of touched on this. Customers know better than anyone what the product should do, so talk to them. I have experience in the Space Center, so I kind of knew the base direction to go, but a lot of the development of Thorium over the past year since I told people about it has been from other people telling me this is what I think should happen. But then they'll tell you if they let you what they want. So this is actually a fun graph that I calculated this past week of the number of issues submitted to my Git repo by month. And you can see that all of this here is me just keeping track of things myself, using GitHub's issue tracker so that I know this is what needs to be done, prioritizing stuff. And then once it started picking up momentum and getting used, you can see that it started spiking. And then last month, it was miserable, 102 GitHub issues. And I just was like, but it means that they like it and they want it to continue growing and becoming better, so that's a good thing. Yeah, final lesson learned, always been on JavaScript. I love commit script, they are great. And React and GraphQL. Like I said, one of the things that was really frustrating, I'll let you finish reading that, sorry. If you are blind and watching this screen recording, it says, I've got a feeling, bro, I'm all in. Really? It's too risky. They're at a roulette table. He puts all of his chips on Silverlight. The attendant says, no more bets. And then it lands on JavaScript. Lesson learned, always bet on JavaScript. So, and React and GraphQL. I know that Angular and Vue and all of those other front-end libraries are really, really great, and they have their purpose, and someday I'll probably learn them better. And GraphQL is not the end-all, be-all. But man, those two technologies together, along with JavaScript, gave me a really great flow for development. It gave me that developer experience and made it really fun to work on Thorium, so I loved it. Thanks, that's it. That's my presentation. Just kidding, we can demo now. I set up this Thorium server on the internet. It's actually not designed to run on the internet. I'm really sloppy with my subscriptions and stuff. Also, it might not work very well on your mobile device. I apologize. But you can go there right now, and we can run a little space mission. Give me just a second to get control of this. And yeah, so for everybody that, well, I guess I can keep the screen recording. That's fine. Huh? Yeah, sorry. Here's the URL. Yep, so I'm a punk and run it on a weird port. I'm sorry. But that's going to take you to the client screen. which it should just have the Thorium logo and the credits scrolling. Yep, yep. So I'm just going to pop this open really quick and let me, there's that. I'm just going to take off the client and I have all control. So look, there you guys are. You're showing up on my thing. So I'm going to assign you a station. I've already pre-configured these stations, and if you get a station on your screen, just raise your hand and say who you are. So there's flight control, engineer, tactical, operations and sensors and communications, and we'll leave out security. Yeah, you can log in. So training, shoot, I don't know what your screens look like, so let me, wait, I've got to do this. Yeah, okay. So if you come down here, if you log in and come down to the gear, you can click the help button, and that'll give you this on-screen help that you can use to learn how to use your station. So let's just do a very basic simulation really quick, and no, it's not designed well for mobile. Incidentally though, there is a companion mobile app, which I just released last week actually. So you can download it on the Android and Apple App Store. And it just has a few basic features. I'm working on building that out. It's open source too, so if you wanted to work on a React Native application, go to town. So let's do a basic simulation where we are going to be testing some weapons in a solar system called Fallout. No, that's not the name of the solar system, but it is now. So what we need to do is have the flight control officer set course to Fallout using their navigation screen, and you'll see what I'm doing here on my screen to control it from the back end. And we need to get some epic music going too, so let me, I don't know if I can pipe my audio through the system. Let's see if this works. Hopefully it's not too loud. Yeah. Oh, come on. Okay, let's see. I've got, let's do this one. There we go. Now we've got some nice music. So let's launch off into space. And I hope that Google doesn't take this down off of YouTube because of this music. Yeah, let me turn that down just a little bit. Oh, and we need somebody to be a captain. Who's going to be the captain? You can be the captain. Captain doesn't usually have a screen. So, give orders.
Fire the torpedoes.
Designed to run over the internet. So I'm just going to get a starbase here. There we go. So whoever has sensors, you can see what's on your sensors grid there. You can also scan for stuff. I don't have a mission here, that's fine.
Just outside weapons range, sorry.
Oh, that's okay. We can put it in weapons range and you can shoot it.
Or we can just move closer.
Yeah, so let me get the targeting up here. So you'll see that as this contact moves into weapons range, it'll appear here so that Jess can shoot at it.
Within weapons range.
Uh-oh. This is that core feed that I told you about, so I don't even have to have this targeting core here. I can just pull it up here and see, oh, that's who they've targeted. And then let's see, what else can we do? I will send a... I haven't shot yet. I would know if you shot.
Well, I don't have any charge.
So you can charge your phasers from the phaser charging screen.
Sorry.
Terminal scan.
Aha! Somebody's scanning for all. I'm just gonna give. I don't know. Yeah. What?
Phasers fired.
Uh-oh. Hang on a sec. I don't have the sound keyboard set up, but I do have this this is what they use for sound effects at the Space Center nowadays, so... Ah, we fired our phasers! So let me send this message. Whoever's communications can decode that message. What's your position? Engineering? Oh, engineer breaks or fixes things. I'm the one that breaks things, so
I think I invited them on the screen.
that's fine. So I'm going to
Phasers
break
fired.
that. Uh-oh. Obviously, I would have multiple keyboards. You saw how complicated that control room setup was. So I would have multiple keyboards for controlling the view screen. I haven't even shown you the view screen yet. And one for controlling the sound effects. So let's get our view screen set up really quick. Who's the flight control officer? What position do you have? Your operations? Let me, Alvy, I'm going to change you to be flight control so that you can set our course and activate the engines. And while you're doing that, I'm going to set up my screen. I'm going to duplicate screens again, or separate my screens. And if you can't figure out how to get the course set, that's totally fine. It's kind of funny, actually. We have students that come and they do this for their 5th and 6th grade field trips. And then adults come and
Damage report request.
they think that it's like really challenging and hard. And they're like, how can 5th and 6th graders do this? So don't worry one bit. Yeah, let's see. I want to... That's not what I wanted, actually. Not yet, at least. Got it set up right here, I think. Yeah, so that's fine. Okay. Hang on a sec. What's going on here? There we go. There's our view screen. So, I need my mouse cursor back. There it is. Okay, Jess, I'm going to have you do something in just a second. I want to show you how the contextual view screen switching works. Just have to turn it on really quick. So, so it just switched to this generic forward scans thing. Do you want to raise the shields really quick? Yeah, it should be on the shield control screen. Yeah, raise all shields. So as the shield's raised, it shows the shield monitoring there. It's not super complicated, but I was out of it, so. How's the course calculation going? Okay. How about you go to your engine control screen, the one with the warp and impulse engines, and just activate the engines to warp factor 1. Just click that warp 1 button. And switches to this stars view. Oh, come on, you're killing me! It's supposed to time up with the sound perfectly, but that's okay.
Because it's over the internet.
It's, I'm pretty sure it's actually because I'm recording my screen, so my processor is getting hammered right now. But in fact, actually, I bet. No, it's working. Yeah. So, anything else you guys want to see, or anything else I can explain? That's basically what I had to present today. Just do this little demonstration and.
So if he goes faster, does the screen go faster?
Yes. So, Alvy, if you want to hang out for just a second, I'm going to give you more power in your warp engines,
I need more power.
and you can now go warp 9.54.
Speed change warp 9.
So we'll see that speed up there.
Wow. Yeah.
Yeah, it's choppy, like I said. If I stop, so I'm going to stop the stream. Thanks for joining if you were on the stream, and yeah, check out thoriumsim.com.